our Stomp Rocket project yesterday, and that went pretty well, I'd say. So you should see some easy points in Harmony for that. I think I did 15 points. So they're in there. That helped everybody grade just a little bit. But we'll go ahead and keep going in chapter 2 here. Now, the title of this section is kind of long. You got a lot going on here. There's the product and quotient rules. Two separate things there. And then also we'll talk about higher order derivatives in section 2-3. Not all of that in one day though. Today we're just focusing on the product rule, and then we'll just kind of slowly make our way through the rest of it. So got a lot going on here with this. Now, product rule, I need to tell you first when you would use the product rule. Sometimes you can use it, sometimes you can't. So, important stuff here. It is used when you have two quantities. Used when you have two quantities with variables in them multiplied together. Used when you have two quantities with variables in them multiplied together. It's the product rule. So two quantities with variables multiplied together. I put in general the part about with variables. Most of the time it'll be X, but we know other times it might be something else. So typically, if it's X's that you're working with, you'll use the product rule when you have something with X times another something with X. X is usually what we use, but again, it could change, you never know. Now, I'm going to set this up first as just a function. Go ahead and copy that down. It just says f of x equals g of x times h of x. I say times because they're right next to each other. Now, as you start to do these problems, you're not really going to have to know that the first part is g, the second part is h. This is basically saying that your function has something with x in it times another something with x. That's just how it is set up. And now I'll show you how we would take the derivative of that. So this is a little long here. Make sure that you get all this down correctly. It says f prime of x is going to equal g of x times, because it's right next to each other, times h prime of x plus h of x times g prime of x. Now again, you're not going to know what's g and what's h. You're not going to see the g and see the h. You're just going to have one part here with x and another part over here with x. I'm going to call this part 1, this part 2. So to take the derivative, you first go with 1, the first part of your function, multiply that by the derivative of the second part, plus the second part times the derivative of the first part. Now, when you see all of that together with the g's and the h's, it's kind of confusing. I've got h prime here, but just plain old h right there. Same kind of with the g's. It's a little much. So back when I was a senior in high school in calculus class, my teacher taught me something that is a little bit easier to remember when it comes to the product rule. Instead of thinking of them as g's and h's and all of that, I'm going to think of this again as just 1 and that part as 2. This is kind of a catchy little saying that goes with the product rule. So follow with me for a second. G of x, we're calling that 1. So just put a 1 right underneath of G of x. H prime of x is the derivative of the second part. The derivative of the second part. I'm going to call that D2. Derivative of the second part. Okay, now I don't have anything to put in for the plus sign. The plus is still plus. But h of x, that was the second part. I'm going to call that just 2. And then g prime, that is the derivative of the first part. So I'm going to call that d1. Okay, so think about this with me here. 1 d2 plus 2 d1. That's how I think of it every time in my head when I use the product rule. Forget the g's, forget the h's. Think of it as 1 d2 plus 2 d1. It's kind of catchy and it just kind of flows. It flows a lot better than all of that. So as we work on these problems today, I am going to label the first part with x1, the second part with x2, and we're going to do 1 d2 plus 2 d1. It's a lot easier to remember. Okay, so let's go ahead and try some. Directions say specifically that we need to use the product rule to differentiate. Remember, differentiate just means to find the derivative. And we are using the product rule all day today. Later on in this section or in this chapter, it won't always tell you what rule to use. That is going to be something that you have to figure out yourself. So remember, we know what we're supposed to do today, but just for future reference, the product rule can only be used when you have something with x times another something with x, or it might be something other than x. Okay, so let's take a look right here at example 1, and it says f of x equals 3x squared minus 2x times 4x plus 5. Now, we're supposed to use the product rule right here to differentiate. Look at what you have. Something with x times something with x. I'm going to call this part right here the 1, and then that part right there, it's the second part with x, so that'll be our 2. 1 d2 plus 2 d1. Here we go. I'm going to find the derivative following that catchy little saying. Okay, it starts out with just 1. You don't have to do anything to it. I would probably keep it in parentheses, but it's just the very same thing that you had from earlier. 1 is 3x squared minus 2x, but now I have to do d2, which is the derivative of the second part. What is the derivative of 4x plus 5? 4. And those two things eventually are going to get multiplied, so I put that in parentheses. If you're following along with that saying, so far we've done 1d2 plus, and here comes the next part, 1d2 plus 2, which is just 4x plus 5, d1. Now, derivative right here is a little bit more complicated. This part would be a 6x to the first power, or just 6x. And right there, I'll have a minus 2. And there it is. We need to simplify it still, but this is the product rule. 1 d2 plus 2 d1. That saying just kind of helps you remember what order to put everything in. Okay, any questions about how we did that part? That's the only calculus really to this problem. Now I need to simplify. This 4 can be distributed to both of those terms in front. So that'll be a 12x squared and then minus 8x. Then you can go ahead and put the plus sign if you want to, and we'll have to FOIL out those last 2 terms because they're binomials. This will be a 24x squared minus 8x plus 30x minus 10. Now I just need to go through and collect all of my like terms. Forgot to tell you guys that I fixed my smart board at lunch yesterday. So it's working now, finally. It was giving me fits first period, but since then it's been okay. So combining like terms, this will be a 36x squared, then negative 8 minus 8 plus 30, that is a 14x. And then you still have the minus 10. So that would be our derivative for this function. Product rule, 1d2 plus 2d1. Any questions about that? All right, well, let's keep going here. I think there's 4 examples today, so not too bad. Now, here comes example 2. F of x equals the square root of x times the quantity 3x squared plus 2x plus 5. Okay, well, product rule. You've got something with x, this will be our 1, something with x times something with x. The 2 here is quite a bit bigger than the 1, but that is going to work for our product rule, 1d2 plus 2d1. Now hang on just a second. I don't really like radicals when I do derivatives. What's another way to write the square root of x? X to the 1/2 power. I should probably fix that before I start to do anything here. So again, that little term right there is the 1, and that big quantity in back is the 2. I haven't taken the derivative yet. That is still the original function. Now, I will say that of all the problems today, this one is possibly the most complicated because of that rational exponent. So follow very closely here. I'm going to start my derivative and 1d2 plus 2d1. Here I go. 1 is just x to the 1/2. You can put it in parentheses if you want. I just kind of left those off. d2, derivative of this would be 6x plus 2. The derivative of 5 back there is just 0, so I don't need it. Okay, 1d2 plus 2, which is that whole thing, 3x squared plus 2x plus 5, d1. Now, taking the derivative, I'm going to put it in parentheses back there, but taking the derivative of x to the 1/2, bless you, I'll have to pull the 1/2 out front and then make it to the 1 less power. Think about subtracting 1 right there, or better yet, subtracting 2 over 2. That will end up being a negative 1/2 power. So this always looks kind of funky on the PowerPoint with the fractions, but that last term there is 1/2 x to the negative 1/2 power. That is the d1. 1d2 plus 2d1. Now the messiest part of this problem is the simplifying. It seems like that's true a lot in calculus. The calculus part is not too bad. 1d2 plus 2d1, that's fine. It's the simplifying part that usually gets pretty messy. So right here, a single term times a quantity, I need to distribute that single term to that quantity. Now let's do this together here. When I take x to the 1/2 times 6x, first of all, the 6, I guess, would get multiplied by a 1 right there, but it would just stay 6. Now I have to take x to the 1/2 times x. What are we supposed to do with our powers when we multiply with the same base? Add our powers. Now this is a 1/2. This is a 1, but if I'm going to add the 1 and the 1/2, I may want to think of the 1 as a 2/2 so that they have common denominators. So x to the 1/2 times x to the 2/2, that will be x to the 3/2. And don't forget the 6 out front. Okay, well, distribute to the 2 back here. That's pretty easy. X to the 1/2 times 2 is just 2x to the 1/2. You don't have to worry about anything there. Then, coming to the back side here, if you want to go ahead and put that plus back down, you can. But there's more distributing to do right here. So, again, follow closely. It gets kind of messy. I'm going to take 1/2 x to the negative 1/2 times 3x squared. Let's start there. Now, first of all, 1/2 times 3, I guess you could put that 3/1 if you wanted to. So 1/2 times 3/1, that would just end up being 3/2. Now I have to take x to the negative 1/2 times x squared. And again, anytime you multiply with the same base, you have to add your exponents. This has a denominator of 2, which means I want this to have a denominator of 2. So I'm going to change that to a 4/2 power. X to the 4/2 times x to the negative 1/2. If you add those up, you'll get x to the 3/2 power. Again, the fractions look kind of funky on PowerPoint, but this is 3/2 x to the 3/2 power. Now, I'll go ahead and keep going here. Now to the next term, 1/2 times 2 is just 1. So you don't really need to put the 1 there because you're going to have other stuff with it. Now I have to take x to the negative 1/2 times x to the 1st power. But again, with that denominator of 2, I want to think of that as x to the 2/2. So adding the exponents, 2/2 plus negative 1/2, that would be a 1/2 power. Again, you don't have to put 1x to the 1/2. You can just do x to the 1/2. Then, last term, 1/2 times 5, kind of like what happened up front. If you want to put the 5/1, you can. That'll just end up being 5/2, and the x doesn't really have anything to multiply with, so that's still just x to the negative 1/2 power. There's a little bit more that we're going to do, but any questions up until that point? Again, this is the hardest one of the day, I promise. I didn't save the best for last. I went right here with example 2. But I'm going to start to search for some like terms. It's a little messy, but this has x to the 3/2. That has x to the 3/2. So those are like terms, but here again, we're going to have to get common denominators. I need to take 6 plus 3/2. So if you change the 6, or maybe I'll just draw an arrow to it. Oh, this is what happened earlier, giving me fits. It used to be able, oh, no. Okay, oh well. I'm going to just draw an arrow to that, and I'm going to change the 6 to be a 12/2. So when I take 12/2 plus 3/2, that will be 15/2. And it's still x to the 3/2 power. I'm not going to change the power there. It's just a label. Okay. Next couple like terms would be right here. So I don't have to get common denominators. Thank goodness. 2 plus 1, that is a 3x to the 1/2. Now, I would fix this up just a little bit. You can't combine it with anything, but it does have a negative power that we need to fix. And you already have a fraction set up right here. So I would pull x to the positive 1/2 power down with the 2 and just make it 5/2x to the 1/2 power. Okay, we're going to call it a day on this problem. That would be all that we do. I will say when you check your answers in the back of the book, on some of these they might look different. They might get some common denominators here to put everything together. We're not going to take it that far, at least not right now. So just know in the back of the book, it's possible that theirs might be a little bit different. Sure, yes, that would be fine. If you want to turn them back into roots, that works. Anybody else? Questions on that one? We got the hard one out of the way. So I've got 2 more examples, but like I said, they should be much easier. No fractions, not anymore for these. Number 3, f of x equals x minus 1 times x minus 2 times x minus 3. Product rule is when you have something with x times something with x. Take a look at what you have right now, and don't write this down, but you have 1, 2, 3 things with x. That's not going to work for us because our catchy little saying just says 1d2 plus 2d1. There's no 3 involved. So what you'll have to do on something like this is maybe just multiply a couple of those together first. Then you'll get it down to only 2 quantities with x. And it really doesn't matter what order you go in here. I FOILed out those first 2, but again, I didn't have to do it in that order. I could have gone with the last 2 if I wanted, or the first and the last even. There's a lot of options. But once you FOIL the x minus 1 and the x minus 2, you should, once you combine your like terms, you should get x squared minus 3x plus 2. And it's still times x minus 3. So this is my 1, and that is my 2. And I can start the derivative now, 1d2 plus 2d1. All right, every once in a while you have to fix up the function first. So 1 is just x squared minus 3x plus 2. d 2, derivative of x minus 3, what is that? Just 1. I'll go ahead and put it there, but it's probably not going to make much difference. So 1d2 plus 2, which is x minus 3, d1. That would end up being 2x minus 3. So with this first quantity here, I mean, if you want to distribute the 1, you can, but anything times 1 is just the thing. So you can just put x squared minus 3x plus 2. And I would go ahead and FOIL back there. That'll give you a 2x squared minus 3x minus 6x plus 9. It's refreshing when there's no fractions here to work with. So 3x squared, this would be a minus 12x, and then plus 11. That is our derivative. Okay, a lot of times with derivatives, you have to simplify the function first before you can actually take the derivative. Any questions about example 3? All right, well, last one here, example 4. Wouldn't be a good day without a trig function. So f of x this time is just x cubed sine of x. X cubed sine of x. Something with x times something with x. So the 1 is the x cubed, and the 2 is the sine of x. That's how we're going to work on this. Okay, I don't have to rewrite anything. I should be good to just start. So 1 is just x cubed. D2, do you remember the derivative of sine? Cosine. So cosine of x, that's the D2. 1 D2 plus 2, which is just sine of x, D1. Derivative of x cubed is 3x squared. Now, I probably wouldn't fix anything about this term. That is just fine the way it is. But I do need to tell you something important about this part. It is tempting, very tempting, to multiply the x and the 3x squared, but the x is with the sine function and the 3x squared is not. So I would probably rearrange that order and again leave that part alone, but write that last part as 3x squared sine of x. That is simplest form if you want to just leave it like that. You know, back of the book, I'm going to put this up here just so you can recognize it later. The back of the book might factor out an x squared on something like that and then leave that as the answer. I'm not going to ask you to go that far with it, but I do want you to know that that's probably what they're doing if their answer looks a little bit different. All right. Any questions about that? Okie doke. Well, assignment is here. This should be C35. Still have about 20 minutes left, so that's pretty good. From page 154, we're doing 1 through 6, and then some randoms, 13, 14, 33, and 37.